you have a good weekend? Me too. I am excited because today we get to review, put everything together that we've been learning, and also have the challenge of some word problems. So if you're ready, give me a big smile, rub your hands together, give me a great big, oh yeah, because here we go. First question, what fraction of my erasers are yellow? Don't take all day. What do you think? What fraction of my erasers are yellow? We just did an event last night. Here, I'll talk while you're counting. We just did an event last night where we had to get inventory for 300 boxes, and each box had about 15 to 20 items in it. So it was important that we know what percentage and what, so this came in with calculations that we were doing last night, only a little bit smaller scale for you. Okay, you got it? How many erasers total? Did you figure that out? All right, did you get 10? 10 erasers total. Good. All right, and how many are yellow? There's only one. So remember, the numerator is what we're talking about. The denominator is how many makes a whole. Okay, how many are blue? What fraction of my total erasers are blue? Okay, still at the bottom is 10. That's right, that's right. Okay, what fraction? So don't just tell me 7. 7 tells you how many make, that we're talking about, but how many make a whole? 10. All right. You think you're doing pretty good, huh? What about this? If I have, suppose I have 3 more erasers, and I put them there. Now, what changes in these two? Okay, what fraction are yellow, and what fraction are blue? What changes? Does the top change? Or does the bottom change? Yeah, the bottom changes, doesn't it? So instead of being 7 out of 10, it's actually 7 out of, I added 3. So that's 7 out of 13. Good, exactly, good. Okay, so you're warmed up? You ready for the real review? Okay, let's go ahead and do it. So I'm gonna make myself disappear so we can use the whole page. All right, so we're gonna move these off to the side. So we already worked with my erasers. Now we're going to work with my pencils. Suppose I have a pack and I have 15 blue pencils and I have 20 red pencils. Okay, I want to make packets of them. Say I'm giving them away as prizes for students. Lots of packets, okay? That's not how many packets, it's just an example. And each one I want to have the same number of red and blue. Oh, wait, that didn't come out right. I want to have, each packet is identical. Packet is the same, identical. Okay, so what I want to know is how many red go in each and how many blue, so it comes out even with no leftovers. Okay. I'll give you a 15-second head start, then I'm going to come in and we'll talk about it. Okay. If you're stuck, don't worry. I'll be here. So how many red and how many blue? Okay, so you're giving me 2 numbers. One number is for red, one number is for blue. Okay, and then you can tell me how many packets we're going to make. Okay, so how do you even start this problem? So do you remember something we talked about before called the greatest common factor? That's what I want to find for 15 and 20. Okay, so for 15 and 20, all right, what 2 numbers, when you multiply them together, give you 15, where one of those numbers is the same for if we multiply them together, we get 20. Yeah, when you look at 15 and 20, what number pops out at you? What number are you thinking? Yeah, 5, right? 3 times 5 is 15, and something times 5 is 20. Do you remember what it is? Yeah, 4 times 5. So our greatest common factor is 5. That's how many bags we're going to have. or packets. I'll call them bags. All right, how many go in each one? 15 was blue. So, and 20 was red. Okay, so that tells us that we have 4 red and 3 blue go in 5 total bags. So we have 1, 2, 3, 4. Oh, wait, sorry. 1, 2, 3. 1, 2, 3. Okay, let's get rid of that guy. Put a little sticker on him. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See, that worked out. Okay, so that was our blue. And then for our red, we have 1, 2, 3, 4. 1, 2, 3, 4. Imagine those are pencils. All right, so 4 and 8 and 12 and 16 and 20. So we have 5 packets. In each packet, there are 4 red, 3 blue, and we have 5 bags total for them all to come out even. All right, if that makes sense, give me a smile. Good, yay. You ready to try one on your own? Okay, how many of you, where are my kids that love cupcakes? Where are the kids that love the cupcakes? Okay, good. So what flavor should we have? You can just tell me out loud. You can just tell me. I can kind of lip read you. Chocolate. I see chocolate. Okay, and then we got 1 vote for vanilla. Okay, so let's say we have chocolate and vanilla, and you're baking a whole bunch, and you make 24 chocolate, and then you make more than 24, and you snack on them. And you also make 36 vanilla. All right. Let's have a bake sale. I'm going to give you some boxes, and I want to know how many boxes, and in each box, how many do we put of each one? Okay, so you go ahead. I don't know how many boxes. I'm just going to go ... because this can go on. How many boxes, so they're all the same. And tell me how many chocolate, how many vanilla go in each one. Okay, that's right. Your first step, somebody's asking, is it greatest common factor? Yes. That will tell you the number of boxes. Okay, who's going to eat all those cupcakes? I'm pretty sure we will not have a problem with that. Pretty sure we have a lot of volunteers. Okay. Okay, good. I'm seeing a number of you have the number of boxes. Excellent. Good. Here, let me slide that over. Okay, so you're finding your greatest common factor. Exactly. Good. Okay. How do you find the greatest common factor? Okay, so 24 has a lot of different numbers that you can multiply together to get you 24. And 36 has even more. So, okay. So what we're going to do is we are going to find the one that is common to them both, and we're looking for the largest one. Okay, so we're going to do that on another piece of paper here. So let me move myself so we can use the whole piece of paper. Okay. All right. So what we have are 24, and we have a 36, okay? And what 2 numbers multiplied together give you 24? So say you said 3 and 8. Okay, that's great, but the 8 can be divided into smaller numbers, right? So we could say 3 times 8 is 2 times 2 times 2, okay? And then 36, okay? If you said 6 times 6, that's great, but these 2 can be divided into 3 times 2 is one of the 6 times 3 times 2 is the other 6. Okay, so suppose you did it this way. Now this will work. I just want to demonstrate both methods. This is a little bit different than we did before. Okay, so every time I see a number up here that's the same as down here, I'm going to circle it. Okay, I see a 2, I see a 2, I see a 3, but I don't see any more 3s, so I'm done with the 3s. I see a 2 and I see a 2. Okay, now what I want you to do is multiply 3 times 2, and then times 2. 3 times 2 is 6. 6 times 2 is 12. The greatest common factor is 12. That's how many packets you're going to have. Good. Okay, so what does that tell you? So for 24, this is the leftover 2. 2 times 12 is 24. And this one is the leftover 3. 3 times 12, oops, that's a 12, is 36. Okay, so go back to our original problem, excuse me, and tell me how many chocolate and how many vanilla. Okay, so 2 times 12 is 24, so we have 2 chocolate and 3 times 12, and 3 vanilla go in each one. So we have chocolate, chocolate, vanilla, vanilla, vanilla. And we have 12 packets, or bags, boxes, 12 something. Good. Oh, is this helping? All right, you're understanding how this works? Good, yay. Okay, great. So I want to go over a couple of things, excuse me, I want to go over a couple of things with you just to make sure that we have this down. Okay, so I'm going to give you another problem. Are we all done with this one? We're good with this one? Okay, you want to see the other page? Sure. All right, so make sure you ask me any questions so I can answer them for you. Good. Yes, this should be a review. This should be a review. This week we're going to be doing a project. You guys are actually all going to run a bakery. So we got to make sure you've got everything you need in order to do that project together. Okay.